A number when you go to plug this in. The variables that remained white, that would be here, down there, okay, right there. These guys are going to remain x and y. Okay, and generally you'll solve for one of them if you want a certain form and such and so forth. I'm going to leave that for another video. But anyway, let's try it. Okay, let's see what happens. We write the equation of a line. Okay, let's do some examples. Now, when we do these examples, I'm going to ask you guys to rewrite that formula every time you go to use it. And it's going to help you memorize it, yes, but it's going to help you to remember and learn how to use that formula. Okay? So it's important that we rewrite it. And I'm going to write it again right here up at the top. Okay? Alright, so here it is up at the top. Okay? It's y, again, y minus y1 is equal to slope times x minus x1. So just remember what we need in order for this formula to work. We need 1 point and 1 slope. Okay, it's just simple as that. So when you go to through your problem solving skills, when you see a word problem-ish looking problem like these, you need to go and say, okay, what do they want from us? Okay, and you might go all the way to the end of the problem and you might see, give your answers in slope-intercept form. Right there as your clue, they're asking you to write the equation of the line. Okay, and so, you know, right there. So you'll see derive the equations or whatnot. So just kind of keep focused on that, you know. So this is what we're doing, meaning we need 1 point, 1 slope, or at least we need to be able to figure out what we need. We need the information that's crucial to get the plug-in for the formula. Let's try A. Okay, for A, we have the point 10, 3. Okay, and we're here on A. Okay, so we have the point 10, 3. That's my x1, y1. So what? X1 is going to be 10. Y1 is going to be 3. And my slope will be 1/2. Now check it out. That's everything I need, right? Because when I go to plug in to this formula, check it out. These are the guys that need to be filled in with numbers. The y1, the m, and the x1. If it does not have a subscript on it, or if it's not an m, then it stays x or y. So let's plug in the values where I highlighted blue. Okay? Alright, so what do we have? Let's rewrite our formula. Y minus y1 is equal to slope x minus x1. Alright, so here we go, plugging in. Okay, we will have what? We'll have y minus 3 is equal to slope of 1/2 times x minus 10. Now, you're going to go ahead and distribute the 1/2 and simplify everything. Now, I want you guys to see how far do we need to go as far as simplifying. Well, we need to go as far as it takes to get us into slope-intercept form. In case you don't remember what slope-intercept form is. So slope-intercept form is basically what you get when you would take your equation, your linear equation, and you solve it for y. So basically just get y by itself on the left and then put everything into standard form on the right. That would mean your x term first and then your constant term. So what it is, though, when you do have slope-intercept form, here's what you get. It's very simple just to pick out the slope. Okay? So the number that we have multiplied by the x on the x term, in other words, the coefficient on x is the slope of our line. And then the constant term, along with the sign, the constant term basically gives us our y-intercept. Okay, so this number by itself tells you where the graph crosses the y-axis. It's the y-intercept. And I really need to correct this thing. It's not the number alone, actually. It is the number, actually the point 0, b. Okay? Of course, we could say that b is the y-intercept. But remember that the y-intercept does have an x-coordinate that is equal to 0. Okay? So let's go on back. Okay? Let's see where are we with our problem. So back to our problems. Now what you'll notice is along the top, I have now included what's slope-intercept form. Remember, basically we're going to take what we have here for part A, and we're just going to solve for y. So let's work towards isolating y on the left. So I'm going to go ahead and distribute the 1/2 and add, after that I'm going to add 3 to both sides. If you want to pause the video and try that yourself, you could do that right now. Otherwise, I'm going to go for it. So here's how it goes. So our first move, we said, was to take 1/2, the slope there, and we're going to distribute it. So it'll get multiplied by x and then -10. So let's see that happen. So here we have 1/2 x and then 1/2 times -10. So we have a negative term, but then we had what? We had 10 divided by 2, which was 5. So that's why we have -5 there. Now our next move is to finally isolate the the y. Okay, so we're going to add 3. Since 3 is subtracted on the left side there, it's -3. We're going to add 3, the inverse operation. Now here's why, because -3 plus 3 is 0. So now we have y is equal to 1/2 x, -5 plus 3 minus 2. So we have y is equal to 1/2 x minus 2. Okay, we're going to come back to this and we're going to do some graphing in a bit. So we'll take a look at the graph of this one. What I'm going to do is I'm going to call this one y sub 1, as in my first line. Okay, now let's go to part B. Okay, for part B, some separation there. X1 is going to be -5, and Y1, y sub 1, is going to be that -2, right? That comes straight out of our x, y coordinates. And then, of course, our slope is -3. So remember, it's always wise to just kind of summarize your information, just to make sure you have everything you need. So now all this information can go into the slope-intercept form. Okay? And so let's go ahead and plug it in. See what happens. Okay? So now we have y is equal to, and I forgot my subscript there, minus a -2. Now put that in parentheses. Anytime you're plugging in a value that's a negative number into something that's subtracted, especially like y minus y1, and then y1 happens to be -2. So that you don't get confused, you really do need to use your parentheses, okay? Now, just to give you a mental note, I'm going to write in orange what is our value. So we're just plugging in that -2 here. This comes from the point that we're given, okay? So the y minus is from the formula. So remember that, okay? Just kind of be careful with that. Of course, if you're really getting good with this, you can go ahead and go straight to writing y plus 2, which is what it will become in a minute. Other than that, though, when you're starting to plug your numbers in, please use parentheses when you're plugging those negative values in. Okay, so our slope now is -3, and then we have x minus a -5. See, there I go again. And you could use bigger parentheses like I just did, or you can upgrade to a set of brackets if that is something you'd prefer to do. Okay, we didn't need to do that on the left side because, I mean, that's the only parenthesis that I needed. Usually when you nest a parenthesis like that, we'll alternate between parentheses and brackets. We don't really need to do that right now. Let's go on. So we have what? We have y plus 2 is equal to -3, and it'll become x plus 5, right? That's nicer, right? Now we can distribute our -3. Okay, so the next step will look like this. Y plus 2 is equal to -3x minus 15. Careful, we have a -3 times x, and then -3 times positive 5, which is minus. Okay, negative as well. So now we have added 2 on the y on the left. We need to get that unattached from our y and bring it over, and we'll have y alone, right? So we want an inverse operation for adding, and that would be subtracting. So what we do, we're going to subtract 2 from both sides. So it'll cancel here, right? And we'll have y is equal to -3x and what? Minus 17. And this will be our second equation. So I labeled that with a subscript of 2 on the y. Okay. And finally, what do we have here in part C? Okay, part C is interesting because they don't give us outright a slope, but they give us 2 points. So we have to actually use a slope formula. So let's go for it. Let's write that down. Let's see if we can remember the slope formula. By the way, when you have 2 points given to you, we'll call one of them x1, y1. That's point 1, right? And we'll call the other one x sub 2, y sub 2. Okay? So as though it's from point 2. And so when we're given 2 points, we can find the slope. So that's what you need to be given to find slope, to plug into that formula. So here we go. We'll have slope is equal to, go ahead and use that line there. We'll have the difference in our y's, y2 minus y1. Okay, and then divide by, so our denominator is now going to be x2 minus x1. Notice my subscripts are in the same order on top and bottom of this fraction. So I have y sub 2 minus y sub 1. Then in the denominator, x sub 2 minus x sub 1. You want to be subtracting in the same direction for both of those. Okay, let's plug in, see what we got. All right, here we go. All right, so look. Here's what we had, 5 minus 5, right? Because we subtracted the y2 minus y1, right? So, and then in our denominator, we have the -3 minus 0. So what do we get? So 5 minus 5 is what? 0. And we have a -3 in the denominator. 0 in the numerator is fine. It's just fine. Because what is 0 divided by 3? It is 0. So there's your slope. Okay, so now we have what? Let's go ahead and write our information. And now it does not matter which point you use to be x1, y1, okay? It really does not matter. You could use either point in the point slope formula. It'll still work. Okay. Since I have x1, y1 already labeled as 0, 5, I'm going to use that one, okay? And so now on top, I'm just going to go ahead and well, no, right below that, I'm going to go ahead and write my given information for the point slope formula. Okay. So here we go. Sorry about that, guys. All right, there we are. Okay, so now we have a slope of 0. And we have an x1, that's 0. And we have a y1, that would be 5. And now we can plug into our formula. Y minus y1 is slope x minus x1. Write it every time, even if it's quickly, like I just did. It's fine. Just so you write it and you're learning it, you'll remember it. So now we have y minus 5 is equal to 0, and then x minus 0. What's going on over there on the right side of this equation? It's just 0 times a set of parentheses. So what's happening here? The entire right side is going to be 0. So let's clean it up a little bit, and we'll have y minus 5 is equal to 0. And remember, 0 is a number too. Don't pick on 0 and try to make it something it's not, so don't panic. Let's still get y by itself. Remember, keep your eyes on the prize. We're trying to isolate the y variable. So let's add 5 to both sides, and we'll see what we get. Okay, and so we'll have, what, plus 5, right? Cancels on the left, and we have y is equal to 5. Now, what is this equation if it's y equal to a constant? Okay, and by the way, I'm going to put a little subscript of 3 on my y because that'll be my third equation that we want to look at. Okay, so y equal to 5 is what? Okay, look, I'll give you a hint. A really cool way for you to just quickly figure it out, make an ugly set of axes like this, and find where y is equal to 5. Okay, so it's about right here, right? Okay, let's say, where's the 0.15, right? Because no matter what x value you have, y is going to be 5. All right, where's the 0.25? Okay, so what kind of line is it? A horizontal line. Okay, remember, horizontal lines have slope of 0. They're flat plane, right?